Hi everyone, I am Rajeshwari. In my last lecture video, we have already seen about the case study of AlphaGo, and this is the introductions we have seen in last class itself, and the challenging for artificial intelligence that and all we have seen in last lecture video and core concepts. Now we are going to see about the step 4, that Monte Carlo tree search, which is MCTS. It is a algorithm we have to use for prioritize and build this search tree. It composes 4 steps based that it stimulates future sequence of moves, and the policy network guides explorations which prioritize good moves. Value networks evaluates both states at tree leaves. Smart balances between exploration and exploitations. So this is the step 4 for AlphaGo in reinforcement learning, and the first step is a selection, expansion, evaluation and backup. When we have to select the case, and it will expand the process, and it will evaluate the steps, and it goes for backup state. And the next thing is AlphaGo architecture diagram. This is the architect process of AlphaGo in reinforcement learning. First thing is it will record the strong players and self-play with reinforcement learning algorithm by using MCTS. It will roll out the policy and the policy network and value networks which will process and will prediction of move, that is for used for playout and logistic regressions with fast moves, and the prediction of move with these, which is used for node selection and expansion by using convolutional neural network fast, and prediction of wind rate, that is whether we have lose or win, that is by using convolutional neural network case. And the policy network overview is by convolution neural network. This network is the first trained by supervised learning algorithm, and later it refined by reinforcement learning. The trained with KGS datasets is, for example, 29.4 million questions from 1,60,000 games played by KGS to 6 to 9 dan. That is, it is a policy network overview by convolutional neural network. And this is the policy network and simple policy network for movements. The output percentage is given in that blue color, it will mention in that. And the policy network of reinforcement learning is it trained the KGS data sets with the 48 channels. Futures is prepared for next slide explains details, that is, it is prepared in next slide, prepared in that futures in the next slides I will explain in that. So this is the basic channels that they have prepared for convolution neural networks. We have 48 channels in that, and the output prop for next move is we are going for their future trained policy networks by policy gradient reinforcement learning. And the future trained policy network by policy gradient reinforcement learning, it is the training is done by self play. The win rate of reinforcement policy network over the original policy network was 80%. So this is the network policy, and the summary of the table is we have the component, techniques, purpose. That is, the component we have a policy network moves, and the techniques are supervised learning, and the purpose is mimic expert. And the improved policy play is reinforcement learning. We have to improve your self play, and the value network outcome is for deep reinforcement learning regression, and it predicts game outcomes. And if we have MCTS exploration is for guided tree search, and it will efficient for moves. So this is the summary table for reinforcement learning algorithms in case studies for AlphaGo. And the impact of AlphaGo is power proved reinforcement learning can solve real world complex problems. So these are the impact of AlphaGo. In next class we are going to see about next topic. Thank you.